Section 4 is on linear combinations. So today we're going to go over yet another method for solving systems of equations. You're going to notice that these equations are set up a little differently, so we're going to use a different method. And this method is called eliminations or linear combinations. So what we want to do is we notice that the x's are in line, the y's are in line, the equals are in line, and then the numbers are in line. So if that's true, what we want to do is be able to cancel out either the x's or the y's. But right now, 6x and 2x don't cancel, 2y and 4y don't cancel. So what I'm going to do is I'm going to multiply this top equation by 2. And I'm going to multiply everything in there. So that's going to leave me with 12x minus 4y equals 8. And the second equation I'm just going to leave. So I'm going to rewrite it right below that. 2x plus 4y equals 6. And now what I can do is I notice if I were to add these equations, negative 4y plus 4y would cancel. So I'm going to add, straight in row, 12x plus 2x is 14x. My y's will cancel, and that will equal 8 plus 6 is 14. So it's pretty easy to see that x is 1. Just like before, we need an ordered pair, so I also need my y value. So I'm going to go ahead and plug in my x value of 1. I now have 4 equations. It does not matter which one I pick, so I'll just go ahead and pick my first equation to keep it simple. So I've got 6 times 1 minus 2y equals 4. So I'm going to subtract 6 from each side. So I've got negative 2y equals a negative 2. So y equals 1. So my ordered pair here is 1, 1. Okay, so let's go ahead and try another one of these. Example B. So again, I have my x's in line, my y's in line, my equals, and then my values. So I can either cancel my x's or my y's. So I'm going to go ahead and say, let's multiply this top equation by 3. That means I would have a 3x and it would cancel with my other 3x. So that top equation is going to be 3x plus 6y equals 39. And my second equation, I'm just going to rewrite 3x plus 6y equals 6. Now in this case, to get my x's to cancel, if I add them, I would get 6x. So this time I need to subtract. Okay, so each equation is going to be different depending on how you need them to cancel. So now I'm going to get 0 plus, and my y's actually also cancel, and that would give me 33. So my equation says 0 equals 33. We talked about this a little bit yesterday. Sometimes your variables cancel, and when that does, you want to see if your answer is either true or false. Well, 0 does not equal 33, so that is false, so there are no solutions. Okay, what that means is that there are parallel lines here. So there are no solutions. So if I asked you what it looks like, though, just a side note, is that would mean parallel lines. Okay, let's try another one. Example C, 8x plus 3y equals 41, 6x plus 5y equals 39. This one's a little trickier because I'm going to have to multiply both equations by a value in order to get them to cancel. So I'm going to multiply my top equation by 5, leaving me with 40x plus 15y to equal 205. And then I'm going to multiply my bottom equation by 3. So I've got 18x plus 15y equals 117. Okay, so now you'll notice my y's are going to cancel, but only if I subtract. Okay, so I've got 40x minus 18x is 22x. My y's cancel, and then 205 minus 117 is 88. So x will equal 4. Again, I need to plug it into one equation. It does not matter which one I pick. Okay, so I'll go ahead and I'll just pick my second equation here. So I've got 6 times 4 plus 5y equals 39. So that's 24 plus 5y equals 39. So I'm going to subtract 24 from each side. So I've got 5y to equal 15. So y would equal 3. So my final answer is the ordered pair for 3. Okay, so let's try another one. Example D. Okay, it looks differently, but keeping in mind, all you need are the variables, the equal signs to be in line. So my m's are in line, my equals, my n's, and my numbers. So I still need either the m's or the n's to cancel. So I will multiply this top row by 2, leaving me with 6m equals 8n plus 10, and my bottom row by 3, so that'll give me 6m equals 9n minus 18. So in order to get my m's to cancel, I would have to subtract. So that would give me 0 equals 8 minus 9 is a negative 1n. Watch your signs here. 10 minus a negative 18 is a plus 18. Okay, again, watching your signs really carefully here. So to solve for n, I would subtract 18. So I'd have negative 18 equals negative 1n. Divide by negative 1, and n would equal 18. Again, I need to solve for m. So I'll grab this second equation. So I've got 2m equals 3 times 18 minus 6. So I've got 2m equals 78. So m will equal 39. Now, in order to write an ordered pair without an x and a y, we're going to write them alphabetically. So m and then n. So 39, comma 18 will be my final answer. And then let's try one story problem. At a restaurant, 4 hamburgers and 2 fries cost $27.10. At the same restaurant, 3 hamburgers and 4 fries cost $25.20. Find the cost of each. Okay, so if I write the equation for the first restaurant, it'd be 4 hamburgers plus 2 fries equals $27.10. At the second restaurant, I have 3h plus 4 fries equals $25.20. So there's my original system. Okay, and if I notice, I can multiply my top equation by 2 so that my f's would cancel. So that would give me 8h plus 4f equals 54.20. And I'd leave my second equation alone. 3h plus 4f equals 25.20. And in order to get my f's to cancel, I would subtract. So 8 minus 3 is 5h. My f's cancel, and that would give me $29. Divide that by 5, and I would get $5.80 for the cost of a hamburger. So now I can use the cost of a hamburger and plug it back in. So I've got 3 times 580 plus 4f has to equal 25.20. So if I subtract the hamburger cost, 4 fries would leave me with 780. So 1 fry would be $1.95. Okay, again, to make an order pair, alphabetical. So fries before hamburgers, $1.95, comma $5.80. Okay, so elimination, depending on which one you like better, sometimes you can organize it so you can use this method, but it should be pretty good. So go ahead and write some questions and see what you have learned.